Yeah, okay, so in this case, we want to find the 11th term. R is negative 0.95, right? And then A1 is this one. So A sub 11 is negative 122 times negative 0.95 to the power of 10. So that is negative 73.05.
Will you tell us how many decimal places?
Yeah. Okay, next one. Okay, so geometric means is the same idea as arithmetic means. If you take a geometric sequence, and if you grab any two non-consecutive terms, all the ones in between are geometric means. So let's write a sequence that has, with an H, 3 geometric means between 264 and 1.03. So 264 is here. And then 3 geometric means 1, 2, 3. And then, let me give myself some space here. So 264, 1, 2, 3, 1.03125. So, what's n? How many total? 5. So n is 5. A sub 1 is 264. So, okay, so we know that A sub n is A1 r to the n minus 1. So 1.0, A sub n is the last one, right? Okay. It equals 264 r to the power of n minus 1, 4. So let's divide by 264. 1.03125 over 264 is r to the 4. Okay, so to get rid of the 4, we're going to raise everything to the power of 1/4. So r, wouldn't you know it, is just 0.25. It's a quarter. I know, it's weird. So we multiply this by 0.25, and I get 66. Then divide by 4, 16.5. Divide up by 4, 4.125. And if you divide that by 4, you get 1.03125. Yay!
Yay!
Okay, so yeah.
So if it has 3 terms or 5 terms, like an odd number of terms, I don't know if this makes any sense. You can't just add them and divide them by 2, right?
No.
Like
No, you would have to divide them and then
never mind. I don't know why.
Raise it to the power of 1 over however many steps. Yeah. Okay, so that much for geometric sequence. Let's talk about geometric series. Geometric series is when, you take all this and you add them up, okay? So you take a sequence and you just find the sum of them. Just like we did for the arithmetic series, we're going to derive a formula for this. Okay, so Sn, right, would be, okay, the first term is A1 plus, the next term in a geometric sequence is A1 times R plus A1 times R squared plus, right, dot, 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 plus, 3 dots, plus A1 times R to the n minus 2 plus, I'll tell you, A1 times R to the n minus 1. So this is the very end, right? The last one is A1, R to the n minus 1. And then the one right before it is R to the minus 2. Now what we're going to do is we're going to do another one, but this time we're going to write up R times Sn. Okay? R times Sn. Oh, why does it keep doing that? Okay. So let's see what R times Sn would be. It would be A1 times R, A1 R squared, A1 R cubed, blah, 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 right? So you get the same terms but offset by 1, right? And because afterwards we're going to like add and subtract these, I'm going to align them with their respective terms. So I'm going to start writing from 1 over. So A1R plus A1R squared plus dot, 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 plus this one would be A1 R to the n minus 2, A1 R to the n minus 1, plus an additional A1 R to the n. Okay? Now what we're going to do, we added the other one, but we're going to subtract this one. Okay. So when you subtract this, you get Sn minus Rsn. Okay, let's subtract. What do I get? A1 from here. When I subtract this, what do I get? 0. This gives you 0. This gives you 0. This gives you 0. And what about this one? So this is another like plus 0. If I subtract, what do I get? Minus A1 R to the n. Okay, let's clean this up a bit. Factor out an Sn, 1 minus R, is equal to factor out an A1, 1 minus R to the n. Oh, I can totally solve for Sn now. A1, 1 minus R to the n, all over 1 minus R. And now you're thinking to yourself, okay, there is no way in heck I would have thought to do this. Well, guess what? You don't have to. That's what mathematicians are for. Okay? But we would like to, see where they came from, right? As much, street cred as they have, right? We still want to, sort of be like, okay, explain thyself. Now, this is totally fun, but what if you don't have that, all of the information that you need, right? So what if like you're missing, for example, n or whatever. So here's another version of this. You can take this step and you can do S sub n, right? So what is this? This is A1 minus A1 R sub n over 1 minus R, right? If I distribute the A1 back. Okay, now take a look here. This is AN minus. Okay, guess what? Okay, let's see what this is. This is kind of like a little bit of a stretch. Okay, if I take A1 times R to the n minus 1, and if I multiply by R, what does that give me? A1 R to the n minus 1 plus 1, right? Which is A1 R, correct? I'm sorry, R to the n, right? So A1 R to the n is really A1 R to the n minus 1 times R. Okay? So A1 R to the n is this times that. Why are you doing that, Miss Malikian? Well, let me tell you. I'll tell you why. So this is all over 1 minus R. Okay? But now, who can tell me what this is a formula for?
That's the one we just learned, right?
Which?
Explicit.
That's A sub n, isn't it? So we get Sn is equal to, oh, I made a mistake here. This was supposed to be A1. Sorry, guys. So this is A1 minus A sub n times R over 1 minus R. So that's another formula. Okay? And it's a little bit more complex here than in the arithmetic version, but they're both here. Okay? Of the first 11 terms of the geometric series. So what I want is S sub 11. All right. What's R? Negative 6 over 4, negative 1.5. So S11 is equal to, which one of the formulas are we going to use? So this one, you use it if you know the last term, right? Formula 2, which we don't. So we're going to use formula 1. So that's A1, which is 4, times 1 minus negative 1.5 to the 11 over 1 minus 1.5. And that is 140. Okay? All right. Take a look at the next one. Which formula do you think we can use for the next one? The second one. So go ahead and use the second one. And let's see what you get for it. Okay. Okay. All right. I'm done. Anybody else done? So for this one, we do get negative 131,068. Okay, let's take a look at the next one. Okay, so let's take a look at this one. We want to sum up from 3 to 8 of this. Okay, so again, how much is n, first of all? N, like we said last time, is 8 minus 3 plus 1, 6. Okay, the first term is a sub 3, right? The first term is negative 2 times negative 2 to the power of 3 minus 1. That's negative 8. 3 minus 1 because it starts when n is 3. Now, so of the formulas, we can actually use the first one. So Sn is equal to A1, 1 minus r to the n over 1 minus r. So this is negative 8. Okay. 1 minus r to the n. What's n? Did we say 6? All over 1 plus 2. That's 168. Okay? So, it's important to note. Huh?
I'm lost. Where did we get 2 for R?
Oh, this is R.
Okay.
Okay, so let's take a look. Okay, hang on. Let's take a look at this one. What is the explicit formula? The explicit formula is A1 times R to the power of n minus 1, correct? So if you just match,
Oh,
okay. All right, so that's R. So here, this number is R. But in here, in this formula, when it says A sub 1, that's the first term of the sequence that you're adding. All right? So that's why it's negative 8. Okay. Now, what if you have the sum of an infinite geometric series? So what if, you have the first number, like 5, and then let's say R is 2. So multiply times 2 times 2 times 2 times 2. Well, you keep multiplying the numbers, the sum is going to be infinitely large, very big, very soon. But what if R is a half? Okay? Then you have, so if you start with the 4, and let's say R is a half, then it's 4 times a half. times another half, times another half. So the numbers will get very, very small, right? Which means there is a little bit of a difference. We're not going to derive this one, but basically what you need to know is this. If the absolute value of r is greater than 1, right? So if r is 1.5, 3, 5, 2, then it increases without limit as n approaches infinity. However, if the absolute value of r is less than 1, then Rn approaches 0 as n approaches infinity. So basically what this is saying is, if r, okay, is bigger than 1, you cannot take the infinite sum because it's just going to go to infinity. So the formula is only for r is less than 1. Okay, and this is the formula. So only if r is less than 1. This is the formula. So when you do this, first you have to say, is it possible? Right? That's what it says. If possible, find the sum. Yeah.
How come that's not the same thing for the arithmetic?
So r is 18 over 24, which is how much if you divide by 6? 2/3. Sorry, 3/4. Okay? And since r is less than 1, we can put it inside the formula. So s is going to be a1 over 1 minus, what's r? 3/4. All right, go ahead and tell me how much that will be. So 96. All right, so this one, r is 0.66 over 0.33, right, which is greater than 1, right, because you get a 2 here, so it's not possible. All right, here, again, this is r, which is 0.65, so the absolute value of r is less than 1, which means it works. And we know it's an infinite sum because it says this, right? So we had to check. So what's the first term? 3 times 0.65 to the power of 1? 1.95. So s is the first term, 1.95 over 1 minus 0.65. And I think that's actually 39 over 7.
Wait, I have a question. Isn't the first term just 3?
So it's n minus, okay, so this starts with 2.
Oh, okay.
Yeah.
So if it's an n equals 1 then.
Right, exactly. Okay, so we'll stop there.